It's not hard. You can say that.
The sections?
Yeah. Yes. I see it in your face.
Oh, we got one hair.
It's not bad. It's just the hard part is deciding what to do because you're going to have like 4 different ways to solve, and sometimes I think it's hard for you guys to realize, oh, this is the situation I do.
So it's kind of like proofs with infinite size.
Well, yeah, easier with proofs.
Every time
It's more methodical than proofs. You know, it's like follow the process sort of thing.
like steps. Yes, I did.
All right, guys, we got the title.
I really don't care.
So close, Christian. Christian and his pen's over there. All right, guys. That is not what happened. Okay. So guys, we are just jumping in with examples. That's what solving log equations is. There's just a lot of different ways you can solve, so I will show you a lot of different ways.
Like how many?
Like 4. 3 or 4.
Wait,
something
so
like that.
is there
Okay.
like can you always solve it in one of the
Yes.
like could you always solve it in one way or you have to
No. You have to like, yeah. You have to pick the right way.
so it might take you a long time.
All right, guys, you got 1 and 2 written down? This is written down?
Yeah, I've already.
You're ready? All right. Okay, guys. So what I see on number 1, do you see how there's a log on one side of the equation but not on the other? Okay, that is your clue to turn it into an exponential equation. So you know how to do this. What would this be as an exponential? Okay. And what is 2 to the 3rd? Okay, and now we're in algebra 1, so add 6. And we get 2. A lot of them do equal 2, I would agree. When in doubt, guess 2.
Oh, I'm gonna write my.
Okay, they don't all equal 2. All right, does that make sense? Easy? Maybe? All right, number 2, does it look like the same type of problem? No, it does not. So, but I do see a log base 6 on both sides, right? Okay. And what about this 2 in front? Where could I put that? Okay. So really I've got log base 6 of x squared equals log base 6 of 16. Log base 6 is the same in both, right? Okay. You're not like canceling it out, but what you're taking the log of would have to be equivalent. So you can just write x squared equals 16. So what is x going to equal? Okay, normally you would say plus or minus 4, right? Does the negative 1 work? No. Why? No. You're like, well, because you asked us, so it probably doesn't work. You guys remember domain? So domain. Franz, you need new friends, okay? All right, that's what the graph of a log looks like, correct? Sort of, right? Domain was always 0 to infinity, like you could only take the log of a positive number. So here, if I try to let x equal -4, do you see how I'd be taking the log of -4? That's not going to work. So positive 4 is it, and you're done.
So could they never be negative?
Not necessarily. Let's say this had been like, I don't know, from the beginning, like -3x in there, then you'd want x to be negative because -3 times a negative would be positive. So you just kind of have to plug it in and make sure that what you're taking the log of is not negative. And it has to be from the original step. Okay. All right. So far, okay. Let's keep moving. Bobby wants free time. All right. Jot down 3 and 4. Okay. Number 3. Looks different again, right? Okay, but I see a plus in between my logs. Multiply. So this is really log base 6 maybe, of x plus 3 times x plus 4, and it equals 1. Now what does it look like? Okay, we are going to have to multiply, and it does look like turning it into an exponential, right? So we are going to have 6 to the first equals x plus 3 times x plus 4. So multiply out that right-hand side, and you get x squared plus 7x plus 12. How do I solve? Okay, because we need a 0 on one side, right? So I've got x squared plus 7x plus 6. Now what? Now we yawn. Alright, so x plus 6, x plus 1. Right? So what are my 2 potential answers? Okay. Do they both work? No. What are we checking? Okay, so when I plug it in, go back to the original. This is a weird color today, isn't it?
Yeah, it's kind of.
I wonder if this is dying. Probably.
Blue. Like a blue. Purple blue. Blue. Alright, if I put a -1 in here, -1 plus 3, that's still positive, right? -1 plus 4, that's still positive. So -1's okay. But what if I plug the -6 in? I get a negative. So cross out -6. That is no good. So our only answer here was -1.
So when you pull your bracket,
Yep, you are plugging it into the original. These things right here have to remain positive.
we could have done that. No.
What do you mean?
The one before that to figure out the negative forward.
Yeah, because if you plug it in, you get a negative, and that's not okay.
So that
To the original, yeah.
Yeah.
Okay.
We'll always do only one that works.
Not necessarily. Yeah. So you just have to check.
If for all of them, if it's negative, it won't work. It's just.
Well, -1 worked.
I meant. Oh, okay. But if it's negative up there, it
Yes.
won't work.
Correct. Yep. All right. Number 4 again looks different. So I've got this weird quantity squared, all sorts of stuff going on. What if you just had the equation x squared minus 4x minus 12 equals 0? Could you do that? Sure. What does that factor into? Not everyone at once.
-2 plus.
How about x minus 6 plus 2? Okay. All right, so I get these two things of x equals 6 and x equals -2, but that's not really what my problem started as, right? So what did x actually represent? I probably should have picked a different variable. It represented natural log of x, right? Do you guys see that, how I replaced this with this? So I really have natural log of x equals 6 and natural log of x equals -2. Now we have one more step to solve. How do I turn natural log of x equals 6 into an exponential equation? E to the 6th equals x. Okay. And then what about this one? Okay. What do you think? When you graph natural log, can you get a negative y value? Think about the graph. Could it equal -2? Like, down there, is that okay? Yeah. Okay. So it's weird. And e to the -2 is not actually a negative number, right? It's a fraction, but it's not a negative number. Okay. Those are your answers and you're done. If you had a calculator on this section, you could then tell me like the decimal values, but without, just leave it as e to the 6th, either -2. All right. We're making good progress. How are we doing? Powering through? You can make it. What? Break? We're gonna like. You can make it. You got 50 minutes left. Any questions so far? Okay. Do you guys see what I mean? Like, it's not that hard, but figuring out which way you're doing it is the tricky part. Okay. Let's not do that. Okay. These two, you already know how to do. Do you want to try them? These are where you have to make the bases match. Remember doing that on a homework assignment a few classes ago? Try that for me. Okay, the blank stares tell me you want help with the first one. What base should I pick? 2. No. Pick the smaller number, it's so much easier. And then remember, you multiply the exponents. I feel like this is the exact problem we had in our notes the other day. Oh, you're getting really good at this one. You should get 2/3. Okay, try number 6. Did you pick 3? Okay. And you got 5/3? Yes?
Yeah.
Okay. So far, so good? Lots of different methods, right?
Yeah, I don't get how that's the same as what we used to.
It's not. It's just reminding you that you can actually still do them that way. Like, it'll just all be combined, and so you got to pick out, like, what's the easiest way to solve it. Okay, jot down 7 and 8 for me, and I will walk you through these, because these are not the same as what you just did. Can you make the bases match? No, that's... Yep, that's the trouble here. Or that's what makes it fun. Can you what? I'm sorry. You could, yes. Yep. What's happening, Mr. Booker? Good job, Leslie.
Hi, Mr. Ritual. How are you?
Feeling Sammy?
Pretty good.
This is a great class.
Skill. Oh, how could I forget?
For the
Get ready for logs.
yeah, we're gonna solve with some logs there. Exciting stuff.
Those
They're loving it.
Statistics?
What's that?
Did those come in? I don't know.
No.
No.
We
No.
use it in one part of statistics, but we don't do
Re-expressing.
It's easier. It's easier than
All right, good.
Statistics. She's transferring into the classroom
Right now. She's done. You mean like
Are we
the
supposed to let them know like head count?
just a good I would, yeah. It's gonna be funny because I don't think I am going. I feel like I'm going to ride back on the bus by myself. Yeah. Be hanging out. Not a cool kid.
I'm not a kid.
What's that? Yes.
Are you?
Tentatively, I think I'm teaching the same thing as this year. No, I'm sorry, guys. I'll just try to do again. You can still come visit me, though. Still come ask me questions.
Every day.
Okay. Every day. It's not working, Bobby. Your facial expressions there. All right, guys. So there was your break, Laura. Now we're ready. Okay, these are different, right? We cannot make our bases match, so we have to do something else. You know, with solving an equation, is how you would like multiply both sides by 2, add 3 to both sides. We are going to take the log of both sides. I always write natural log because it's just shorter, but you could do regular log. You could do like log base 17 if you really like it, but it's going to be messier at the end. So I'm going to take the natural log of both sides. All right, now where does that x go? In front, because it's an exponent, right? This is the whole reason we have logs, is so that we can actually solve equations when the variable is in the exponent. Because without it, there's really no way to solve it other than random guessing and checking, which does not work very well. So from here, I'm trying to get x by itself. I just have to divide by the natural log of 3, and I'm done. And don't go trying to simplify this. You can't. Just leave it alone. That is the end. Okay? It's not bad, right? Yes. Because natural log of 15 is actually like e to some power, and the denominator is e to a different power, and so you can't reduce them. It doesn't work. Okay. All right, so let's do 8 together, because clearly the exponents got a little messier this time, right? So first step is the same, natural log of both sides. All right, then I am bringing, and put it in parentheses, that x plus 3 out in front, natural log of 6, and then parentheses 2x plus 1, natural log of 5. Now you need your algebra skills. So if you don't have them, go find them, okay? They're hiding from you. All right, we're going to distribute the natural log of 6. So this is going to be x, natural log of 6, plus 3 natural log of 6 equals 2x natural log of 5 plus 1 times natural log of 5, so just natural log of 5. That's not that bad, right? It just looks like a lot now, but you can get there. What are we solving for? X. So we need everything with an x on one side, everything without an x on the other. So I'm going to leave my x natural log of 6 here. What else should I bring over to that side? Okay, so I'm going to do minus 2x natural log of 5 equals, what's going to be on my other side? Okay, so natural log of 5 minus 3 natural log of 6. Just moving stuff around, right? Each step is not that bad. What? Don't put it back. Again, what are you solving for? X. Can I factor an x out on the left? I can. So I've got x times natural log of 6 minus 2 natural log of 5 equals natural log of 5 minus 3 natural log of 6. What does x equal? That divided by that. Perfect. Very specific. I know exactly what you mean. Yes. Now, if you felt like it, you could certainly simplify in that fraction over there, like 3 natural log of 6, that's really 6 cubed, but I doubt any of you really feel like doing 6 cubed. Yeah, okay. So just leave it like that and I'm fine with it. Okay? Not terrible, right? Okay. No, it's really not good. Anybody questions so far? That's the end of 8-5. So circle on your homework 1 through 10. No. Sure. I know, you were expecting more, weren't you?
And then we only have 10 minutes.
We got a quick 8-6, yes.
That was
8-6 should be, although we got through that really quickly, so you guys were
Oh, did you sign up?
ready.
Yeah, for the whole thing. How about
Yes.
we make it even?
Start on 1 through 10.
Oh.
If I had given you 20 problems and said do evens, you'd be totally happy, right?
Yes.
Well, that's that. That's what we're doing for 8-6, yeah. Okay, so everybody's okay with 8-5? All right, let me stop this video and